Hey there. So in this video, we're going to graph this function that we were working with, y equals 4x squared minus 4x all over x squared minus x minus 6. So some of the things we already had were our vertical asymptotes and our horizontal asymptotes, but let's follow the checklist or the steps for graphing rational functions. So we're going to factor completely, which we already did. We're going to find the domain. So the domain is for a rational function when you have a p of x over q of x. So we don't want, for the domain, where q of x cannot be 0. The denominator can't be 0. And then we're going to find our intercepts. So for this function, the domain, so we already factored completely. So let's find the domain. I know that the denominator can't be 0. So x minus 3 times x plus 2 cannot be 0. So we're going to exclude the values that make it 0. So we're going to exclude x equals 3, and we're going to exclude x equals minus 2. So the domain then is minus infinity to negative 2 comes up first, right? You always read things from left to right. So minus infinity to minus 2 not included because it can't be equal to 0. Union, then minus 2 to 3, union 3 to infinity. Right, and if you think about this on a number line, you would have negative 2 and 3. And you would have open circles around that because you don't want to include them, but then everything else is okay. So you will shade everything else. And so that's where this interval is coming from. So that's our domain. So now let's go on to the intercepts. So let's find the y-intercept. So the y-intercept, we find it by setting x equal to 0 and solving for y. So when I set x equal to 0, then I have my function is y equals, and I can use either one. So I'm going to have 4 times 0 squared minus 4 times 0. So that's just the whole thing is 0 over, so the denominator really doesn't matter. I just want to make sure that I don't get 0 over 0 because that would be a problem. So I get 0 over negative 6, which is 0. So our y-intercept is 0, 0, which means 0 is also an x-intercept. But let's go to the x-intercepts. So x-intercept is we set y equal to 0 and solve for x. So we're going to have that y equal to 0, so it's going to be 0 equals to, and I'm going to use in this case the factor form. So 4x times x minus 1 over x minus 3 times x plus 2. Right, and a fraction is 0 when the numerator is 0. So in this case, I'm really solving for just the numerator. So 4x times x minus 1 equals 0. And when you have a fraction, if the denominator is 0, then your whole fraction is undefined. So the only time that a fraction is going to be 0 is if the numerator is 0. So here I had then either x is 0 or x is equal to positive 1. So those are our x-intercepts. And we already have our vertical asymptotes from above. So vertical asymptotes were, what did we find them to be? It was the same as our domain, right? So vertical asymptote was x equal to 3 and x equal to negative 2. So from our domain, but also way up here when we find our vertical asymptotes, x equals 3 and x equals negative 2. Now we need to see what's happening around those. So this is where we're going to check, right? It says find vertical asymptotes, which they come from the denominator in our domain, but we want to check the test points to the right and the left. So this is where I'm going to go, okay. So for x is equal to 3, let's do a table of values and see what we get. So x and y is equal to this function, right? 4x times x minus 1 over x minus 3x plus 2. So the factor form is kind of nice because I'm checking when x equals 3, right, we can try 2.9 and 3.1 just to see what happens. And so, and I know right? For our vertical asymptote, we're either going to positive infinity or we're going to negative infinity. So I really just want to see, okay, when I put in 2.9, do I get a positive or a negative? If it's positive, that means we're going to positive infinity. If it's negative, that means we're going to negative infinity. And we already did this in the previous video, but if you play it in again, notice that you're going to have 4 times 2.9 times 2.9 minus 1, which is positive. So the whole thing in the numerator is positive, divided by 2.9 minus 3, that's negative. And 2.9 plus 2, that's positive. So negative times a positive is negative. So you're dividing a negative by a positive, so it's going to be negative. So to the left of 3, we're going to be going to negative infinity. To the left of x equals 3. And then to the right of x equals 3, now everything is positive. The numerator is still positive, right? 4 times 3 and 3 minus 1, those are all positive. Now 3.1 minus 3 is positive, and this 3.1 plus 2 is still positive. So positive divided by positive is positive. So we're going to positive infinity to the right of x equals 3. And then you do the same thing for x equals negative 2. So we can try negative 2.1 to the left and negative 1.9 to the right and see what happens. So let's see here. When I put in negative 2.9, so 4 times negative 2.9, that's negative. But then negative 2.9 minus 1, that's negative also. So I have negative times a negative, so that's positive. And negative 2.9 minus 3, that's going to stay negative. And negative 2.9 plus 2, negative 2.9 plus 2 is going to give me a negative 0.9. So I have negative times a negative, which is positive. So that means that we're going to positive infinity to the left of x equals negative 2, right? If you think about the number line, x is negative 2 here, then negative 2.1 is to the left. And then negative 1.9 is on the right side. So negative 1.9, plug it in, so that's negative, that's still negative, negative times a negative is positive again, over, and now negative 1.9 minus 3, that's negative, but now negative 1.9 plus 2, that's positive, so we have a negative times a positive, which is negative. So negative, positive divided by negative is negative, which means that we're going to minus infinity to the right of x equals negative 2. And then we have a horizontal asymptote at y equals 4. That looks like a G, let me fix it. So at y equals 4, we have a horizontal asymptote. And so now we can sketch the graph. So let's see if I can do this justice. I'm getting better with my tablet. So this is our x-axis, this is our y-axis, and let's plot the things that we know. So I know my domain, so I got a vertical asymptote at x equals 3 and x equals negative 2. So we're going to go to x equals 3, so 1, 2, 3, and I have a vertical asymptote there. And we always draw asymptotes as dotted lines. And our other vertical asymptote is at x equals negative 2, right? These are vertical lines, so they're x equals. Okay, and we have a horizontal asymptote at 4. So 1, 2, 3, 4, not drawn to scale over here. So that's our horizontal asymptote. And so now we need to figure out what's happening. And this is where our work from up here comes in handy. So let's start with the intercepts. So my y-intercept was 0, 0. And our x-intercepts, so I didn't write them as points, huh? So the x-intercept is x is 0, y is 0, or x is 1 when y is 0, right? We set y equal to 0. So we have 0, 0, and 1, 0. So our x and y intercept match up at 0, 0, and then the other x-intercept is 1, 0. And what was our y-intercept? We found our y-intercept was, oh, we already did that. So, okay. And this is where, okay, now what? And this is where the work of the vertical asymptotes comes in handy. So we said, so let me highlight this part, right? So this is what we're going to use to kind of finish off the graph. I'm not doing a good job highlighting. But I know that to the left of x equals 3, we go to negative infinity. So that means that to the left of x equals 3, we go to, we said negative infinity. So over here, the graph is going down towards negative infinity. And to the right, we went to positive infinity. Right, as x going to approach 3 from the right, we went to positive infinity. So that kind of gives me an idea that this is likely doing this. And then here, let's look at negative 2 for our next asymptote. We have a vertical asymptote at x equals negative 2. So what did we say at negative 2? To the right of negative 2, we're going to negative infinity, and to the left, we're going to positive infinity. So this is the left. So when you're to the left of negative 2, you're going to positive infinity. And when you're to the right, we're going to negative infinity. So I'm kind of seeing this. Let me fix that. So we're sort of having this, right, as we approach an asymptote. The graph grows along the asymptote. And then here, to the right of negative 2, we go to negative infinity. So I have this goes to negative infinity, this goes to negative infinity, but remember we have to cross the axes there and there. So that means that the graph must come from negative infinity, go here, and then it has to come back down, and then continue on to negative infinity. And there are things that we still need to know. Like some of you might be wondering, well, how do you know that it goes there and not all the way up? We can't really figure that out right now. So this is where you have a local maximum. And when you're in calculus, that's where you're going to find exactly where that point lies. So this is a very rough graph of what we think it looks like using our found work, right? So following the list factor completely, find the domain, find the intercepts, find your vertical asymptotes, find your horizontal asymptotes by doing long division, sketching the graph, then is putting all of that together. And this is the work doing all of that. So the main thing is when you find your vertical asymptotes, find the behavior along that asymptote, because that helps you decide where the graph goes. And I graphed it on Desmos, and this is what I got when I graphed it, which is pretty much what we have in a much better quality than my little chicken scratch. But this is the same graph. Okay, so the next thing we're going to graph is, so what I want you to do is graph y equals x plus 1 over x squared minus 5x plus 6. So what I want you to do is to find the 6 things. So factor completely, but mainly find your vertical asymptotes and horizontal asymptotes. Find the intercepts as well. Go through the 6 steps and see if you can graph it. For this one, I am not going to record a video, but I will write up the solution and post it on Canvas for you. Okay,